Hi everyone, this is the video lesson for 5.5, the derivative of y equal to 10x, part 2. If you haven't watched part 1 yet, please go back and watch it before continuing. In the first part, I've talked about the 6 different cases, and I want to kind of reactivate this in the general form. So instead of saying y equal to sine x, I'm now looking at y equal to sine of f of x, and so on. And again, with practice, you're going to be able to write this out without deriving each case each time. So what I mean is, if you're looking at y equal to sine of f of x, y prime equals to cosine f of x times f prime of x. And again, you can put some brackets to separate that. In the second case, if y equals to cosine of f of x, y prime equals to negative sine of f of x times f prime of x. In the third case, if y equals to tan of f of x, y prime equals to secant square of f of x times f prime of x. And in the previous video, which I'm going to reactivate and reiterate, the last 3 cases, this is beyond your textbook. They don't really talk about cosecant, secant, cotangent, but I do want to show you more in terms of learning more skill sets. So I think this will add value to you in terms of understanding all 6 cases. So if y equals to cosecant f of x, y prime equals to negative cosecant f of x times cotangent f of x times f prime of x. So notice again, you multiply once by f prime of x, not twice. Case number 5, if y equals to secant f of x, y prime equals to secant f of x times tan of f of x times f prime of x. And again, the chain rule means you multiply the derivative once. Last but not least, case number 6, if y equals to cotangent of a function, let's call that f of x, y prime equals to negative cosecant square of f of x times f prime of x. So again, those are the 6 cases in the general form. Back to example 1. Determine the derivative of each function. So again, if y equals to tan x, y prime, that's secant x, that's it. You're done. Part B, if y equals to tan of 5x, y prime equals to secant square of 5x times the derivative, which is 5. And again, I'm going to make a mistake here. I see this a lot, and I want to make sure that this does not happen to you. So the mistake I see all the time on a quiz, on a test, on the final exam is one student's going to take 5x, they're going to multiply it with 5, and they write down secant square of 25x, and that's simply not true. No, please don't do this. Now, the correct answer is you bring the 5 to the front, then you copy secant 5x quantity square, just like that. So again, it's not enough to know what to do. You should know what not to do in order to enhance your understanding. Part C, y equals to tan x squared. And again, for some students, they like to express this in exponent form. They see it better. So you can write down tan x in brackets to the power of 2. Y prime equals to 2 times tan x to the power of 1 times the derivative, which is going to be secant square x. And again, at this point, it depends on the textbook. Sometimes it even depends on the teacher. But if you want to rewrite this in terms of sine and cosine, you can. And tan x, of course, is sine over cosine. So you can write down sine x. And secant square x is already cos square x times another cos x. So it's going to be cos x to the power of 3. So I'm going to put a box around both cases just to show you that they're both mathematically right. And it just depends on the textbook. It may even depend on your teacher to figure out which one that they're expecting. Now, part D. y equals to open bracket, tan x minus cosine x, close the bracket, to the power of 3. Y prime equals to, bring the 3 to the front, copy everything in the brackets to the power of 2. Don't forget to multiply by the internal derivative. When you differentiate tan x, that's going to be secant square x. When you differentiate negative cosine x, that's negative sine x, which is plus sine x. So I'm going a little bit faster. I hope you've done enough homework to stay connected here. And of course, if you like, you can just bring secant square x plus sine x at the front and leaving the perfect square at the back, just like that. Again, let's put a box around that. Okay, so that is example 1 so far. Let's move on to example number 2. In example number 2, the question says determine the equation of the line tangent to y equal to 2 tan x, where x equals to pi divided by 4. So here we go, step 1. Y equals to 2 tan x. Y prime equals to 2 secant square x. Since you're looking for the slope, that means for x equal to pi over 4, m, which is the slope, equals to y prime of pi over 4. And in this case, that's going to be 2 times secant pi over 4 in brackets square. Now again, you can use the calculator, that's fine, but you can also do this mentally. You can even think about the special triangle. And for others, you might even break this down in terms of cosine. That works as well. So secant pi over 4 is 1 over cosine pi over 4. Let's put that in brackets to the power of 2. Now I'm going to draw the second special triangle on the side very quickly, just to show you that you could do it based on the second special triangle. And again, that's the isosceles right triangle. Each angle is going to be 45 degrees, or pi over 4 in radians. It's going to be 1, 1, and root 2. So I'm hoping you can see that cosine of pi over 4, this equals to 1 over root 2. Let's write this down. So the slope is going to be 1 over root 2 in brackets quantity squared. This means the slope equals to 4, but I want to make sure you see this. So 1 over root 2 is simply root 2. And of course, root 2 squared, this is going to give you 2. And 2 times 2, that's going to be 4. So the slope equals to 4. Now you go back and you want to find the coordinates, and the fact that you're given x, you want to go back and find y. So in this case, y equals to 2 times tan of pi over 4. And again, y equals to 2 times 1, which means y equals to 2, or more importantly, the coordinate xy is going to be pi over 4, 2. Again, let's put a box around that. Now, once you have the slope and the point, the rest you've done many times. You write down y equal to mx plus b. The slope is going to be 4. X is going to be pi over 4. Y is going to be 2. Your goal is to solve for b. And b equals to 2 minus pi. I hope you're still connected. Y equals to 4x plus 2 minus pi, or in standard form. And again, you bring everything to one side, set it to 0. Make sure a, b, c are not fractions, not decimals, and the leading coefficient is positive. Or you simply bring it to the right. So it's going to be 4x minus y plus 2 minus pi equal to 0, just like that. Example number 3. That's going to be from your textbook, page 260, number 6. Determine the local maximum point on the curve y equal to 2x minus tan x, where x is in between negative pi over 2 and pi over 2. So I'd like you to try this first, and when you press play again in part 3, I will continue with example number 3. I hope this makes sense.